Okay, welcome to part 3 of the interactive plots lesson. So we just covered the basics of Plotly and how to rebuild some of those interactive plots that we saw with ggplotly. Now we're going to cover some more common types using the different add functions. So there is almost a one-to-one naming convention with the geom underscore and the add underscore because Plotly was made to work well with the tidyverse. And so we're going to start out with add bars and add histograms. And these work the same way as geom bar and geom histogram. So remember that the difference between add histogram and add bar or geom bar is that histogram does the binning for us, whereas bar, we have to supply the heights. This is the same thing as it is with Plotly. So with add bars, we have to supply the X and the Y, which means we have to do the counting ourselves. Whereas add histogram, it automatically does the binning behind the scenes for us. We just have to give it the raw data. And maybe a bit confusingly, we can use these to visualize either discrete or numeric variables. So add histogram will give us both histograms and bar charts. So to demonstrate this, let's take a look at the mtcars dataset. So if I take a look at this, we have MPG, the cylinders, displacement, and a few other measures that we'll look at. But notice that the type of car is in the row name. So this isn't actually a column in the data set right now. It's just listed as a row name, which is an attribute of this data frame. We can actually use a Tibble function to convert this row names to a column and give it the name model. So when I run this now model is in the actual data set. I can use this as I would any other column. So this is just to show you another type of function that is available. Chances are, if there's something that you want to do to a data set, there's a dplyr or a Tibble function to help with it. So just do some Googling if you come across any unique scenarios. So to demonstrate the histograms and bar plots, let's go ahead and create some basic ones. So we'll start out with our data set, mtcars, and we will give it the plotly function. And we'll start out with just looking at MPG. So a histogram of the miles per gallon. Add histogram. So this is going to automatically do the binning for us. So when I run this, here is our histogram. So it's a histogram of the numeric miles per gallon for each of these 32 rows of 32 types of cars. So just looking at the 32 rows there. So one thing that we can do is add the outline to our bars just to get a little differentiation there. So we can use the stroke argument and set that equal to a constant black. And there we go. So now we have a typical histogram that we are used to. Next, to demonstrate the add bars function, actually, let's go ahead and do the histogram again, but we are going to do it for a different type of variable. So mtcars, we'll pipe that to plotly again, but this time we're going to look at cylinder. So cylinder is in the data as a numeric variable. So when I use add histogram, it is going to give me the cylinder as a histogram, just like it did with MPG. But if we really think about the data type here, right, there's not going to be a car with 6.5 cylinders. So this is really a factor variable. It's a discrete variable. So if we want to turn this into a bar chart rather than a histogram, what we can do is actually, let me comment out the first plot so we can just focus on the second one. So we can actually convert this to a factor in our plotly statement. Now, when I plot this, it's treating this data as a factor, and it's not giving me a histogram now. Now it's giving a bar plot because of the data type change. So that's how we use add histogram for both bar charts and actual histograms. So next up, we'll demonstrate how to use add bars when we have to count the data ourselves. So to count the data, let me comment these out first. We can use our dplyr functions. So ntcars, we can use the count function, and we're going to count cylinder. And again, we're going to treat it as a factor because I want to get the counts for each of the different levels. So that gives me this data set here. And then, so this is going to be the heights of my bars. So if I pipe this now to add, actually we have to do it to Plotly first. So Plotly, x equals cylinder, and we'll do y is equal to n. So y is equal to the height is the count. And then we'll do add histogram. But we've already calculated the height, so we need to use add bars now. So when I run this, this gives me the same plot that we saw before, except now we used a different function to get it. One thing that could be useful, though, is to sort these bars according to either descending or ascending height, right? When we do that, that's called a Pareto chart. So a Pareto chart is when we have these factors sorted by descending order. So this 8 should be first, followed by the 4, and then by the 6. So it gives us our tallest bars first, the most important ones, and then decreasing in emphasis as we move left to right. To do that, we actually have to modify the underlying data. So the function that we're going to do to modify those counts is going to be a mutate. So I want to modify the cylinders, and the function that we're going to use is called factor reorder. So FCT underscore reorder. And if we take a look at that function, it's from the 4cats package, which is automatically loaded when you load the tidyverse. It is going to reorder factors based on the values of another variable. So that's exactly what we want to do. So we want to take our cylinder and reorder the levels. So factor reorder. We're going to reorder the cylinder factor based on the values of n, and we want to put it in descending order. So dot descending equals true. Now when we pipe this, we've modified the underlying levels. So the data stays the same, just the attributes of this variable have changed. It now has levels in a different order. So now when I run this, we get our Pareto chart with the bars sorted in descending order. So that's another useful way to use add bars, is we can manually specify what order we want them to be in. So here's an exercise for you to try. And we can also polish the plot by making it a Pareto chart and adding data labels like we saw in the previous video. So go ahead and give that a shot. So next up is box plots. So we've worked with box plots a lot, all right? That gives us a visual of the 5-number summary and a way to compare groups for a numeric distribution. So we saw how to do it with ggplotly earlier in the tutorial. And one thing that I'll mention again is that we need to have the plot in the y aesthetic. We need to have the numeric variable in the y. So we have to create vertical histograms in order for ggplotly, or vertical box plots for ggplotly to work correctly. But with Plotly building it directly, we can create numeric, or excuse me, we can create horizontal box plots just as easy. So to do that, we just have to take our diamonds data, and we are going to use Plotly with x equal to price. So my x variable now, my horizontal box plot, is going to be the price, and the y is going to be the different cuts. And then we can do add box plot. And here's what we get. So here is our box plot with that same interactivity from ggplotly, where we get the 5-number summary and we can highlight over all of the different outliers. So notice that all of these outliers are shown. We can actually customize that. But one thing that I'll point out is that the help documentation for Plotly can be a little bit sketchy sometimes. So the best way to kind of view the different options that the arguments can take, it turns out that in order to customize the outliers display, we need to use the box points argument. But how do I know which values I can plug in for box points, right? That's what I'm going to cover now. So in order to determine that, we can actually run this function in our console called schema. When I run that, it brings up the kind of Plotly interactive documentation. So we're going to mainly be looking in the traces. So all right, that's the different geoms. So trace is what is happening behind the scenes. So we don't need to be too familiar with it, but the Plotly is mapping these to JavaScript objects, which are called traces. And this is type trace box. So we go to box, so it might not name up exactly, so box plot versus box, but then we're going to look at attributes and box points. So it says if outliers, this is the value, only the sample points lying outside, ... We can also supply the value suspected outliers, which give us a slightly different version of it, or we could set it equal to false. So that's one way that we can look at what are the different possible values that these arguments can take within our traces. Another way would be the help documentation. So if you take a look at this help doc, this is the single page reference. So it has all of the different traces. So for scatter plots, a lot of the line plots and such are based on a scatter type trace. So this would have everything that we need. So scatter trace would be a good spot to look for starting out. We could also go directly to the box plot one. So if you type in hashtag box, then that brings us to the box trace in all of the different options. You'd have to scroll down a while, but if I just search for box points, there, this tells us that we can either type in all outliers, suspected outliers, or I put in the value false. So let's see what happens when I try suspected outliers and false. So add box plot. We will do box points equals suspected outliers and run that. And notice what happens down here. It's hard to tell on these ones up here, but if I zoom in, the suspected outliers are just empty circles and the actual outliers are filled in circles. So it differentiates between how far away you are from that Q3. So you can look up in the documentation that we just saw exactly how that calculation is done. But we can also just turn the outliers off and just give the lines all the way out to the maximum by setting this equal to false. So there's different ways that we can work with our box plots. When we're making these comparative box plots, though, it can be useful to sort by a particular order, just like we saw with that Pareto chart. It can be useful to sort these in either ascending or descending order so that as we move up across the groups, they're either getting larger or they're getting smaller in terms of the median. So that would be a useful value that we could sort by, is the median. To do this, we're just going to need to use another mutate statement, and we'll reuse that factor reorder function. So let's go ahead and copy our code. And we just need to modify the underlying data. So we'll add a mutate, and we're working with the cut variable now. So cut is equal to factor underscore reorder. And I'll be more formal with the arguments now. So dot F is the factor that we're working with, and we're going to order it based on the values of price, but not the raw values of price. We want to order them according to the median price. So it's going to order these in ascending order based on the median price for each level of cut. And when we pipe that in, it now gives us a sorted by median. So if we take a look at the middle of the boxes here, that line, that is increasing as we move up. So because we modified that underlying data. We could also add the means. So box mean is another argument that we could specify for our box plots, and that gives us a dotted line representing the mean. So the means don't quite line up with the medians because these are all right skewed because of those outliers of the expensive diamonds. So next up is an exercise for you to try. Trying out that factor reorder, but by a different function, in this case, the mean. So scatter plots, how can we do scatter plots in Plotly? So super simple, we just need to use add underscore markers. So a simple example here is we'll work with our MT cars, and we'll create a scatter plot where our X is going to be the weight of the car, and the Y is going to be the miles per gallon of the car. And pipe that to add underscore markers. Run that, and there we go. So we get our same interactivity. We get the X and Y that we saw with ggplotly when we made a scatter plot. So let's go ahead and use this add markers to recreate that application of the Gapminder bubble plot. So to do that, we need to first work with that Gapminder data set. So Gapminder, and we're going to just work with the most recent year. So again, we'll filter down to just a single year of data, and then we'll pass that to Plotly. And we'll just fill in all of our variables now. So the X is going to be that GDP per cap. Y is going to be the life expectancy as usual. And then we'll have size is equal to the population. So that gives us our bubble chart. And then we'll have colored by continent. And then we can add our markers to give us the scatter plot. So there we go. Here is our typical Gapminder visualization. But notice that we're not getting the countries. We're only getting the colors and the continent. So to do that, we have to explicitly specify what the label should be. But to do that in Plotly, for the mouse over text, we actually use the aesthetic or the attribute text rather than label like in ggplot. So we use text equal country. Now when I run this, I get the country added to my mouse over text. But notice that we get the X and Y that is kind of poorly formatted, and there's not any other information. So what if I want to know the population of these specific countries? Because we're not getting a very nice scale. One thing that we can do is just manually specify what goes in the label, and we can customize it by using the paste function. And I'll actually use the paste 0. So all that does is just remove the separators between what I'm pasting. So what we're going to do is I want to paste country. So it's going to do constant value country. Then it's going to give me the data value of the specific country. And then I'm going to use some HTML code. I want to skip it to a new line. So a line break in HTML is separated greater than less than and greater than with BR. And then I want to then say the population, colon, give me a space there, and then give me the actual population from the data. So when we do that, now my mouse over, it gives me country, which is the constant. It gives me the actual data value. It gives me my population. And we can get the population to show up nicer. If you remember, we used that comma function from the scales package. So we could do that again. So scales, comma, population. Now when I run this, I get some commas separating the values of those populations. So that is going to be our nicer version of the mouse over text. But our final Gapminder visualization is going to be visualizing this over every single year, right? We're going to add that interactivity just like we did in Tableau. So to do that, what we can do is specify frame. And this would actually work in ggplotly and in Plotly that we're going to use. So frame is going to be an aesthetic that works with a static ggplot, and then when we pass the ggplotly, it knows how to handle it. But we're going to demonstrate it within the Plotly framework. So to do this, all we have to do is copy our code. We're going to get rid of the filter because we want to specify this data for the entire data set every single year. And just like it says, we just need to set. So we just need to set the frame equal to year. So now when we run this, we automatically get a play and pause button for the interactive feature of the frame. So every single frame is like its own plot, and when we play, it skips through and moves the points according to the year. So that is that final Gapminder visualization that we recreated using pages in Tableau. So pretty neat, same outcome in two totally different softwares. So one with code and one with kind of point and click, drag and drop tools. So there is an exercise for you to do and incorporating some previous ideas as well. So next up is going to be line plots. So how can we do line plots in Plotly? So there's two ways, just like with histograms. There's two ways that we can do this. First one is with add paths, and the second one is with add lines. The only difference here is that add paths connects the dots according to the row order. So how that data is ordered matters, versus add lines connects the dots according to another variable, which will usually be your X variable. So if your data set is sorted properly, according to time, if you're making a time plot, then we're going to get the same result. So let's go ahead and demonstrate that. So we're going to work with the sunspots data, which we've seen before as a time plot when we first introduced ggplot. So we have different years and the value of sunspots for each year. So we'll take our data sun and pass that to Plotly. And my X will be year. My Y will be sunspots. And we'll first show it with add paths. And there we go. Here is our interactive line plot. So we can get the mouse over text of the X and Y for every single point along this plot. Same thing for add lines now. We can just copy the code, change this to add lines, and we're going to get the same exact result. But to demonstrate the difference, let's change the order of our data. So for some reason, let's say my data is ordered according to the sunspots. So it's ascending order for sunspots. When I run these now, take a look at the result. My paths tries to order it based on that default order of the rows, which is according to sunspots, which doesn't really make sense when we're connecting the dots. Whereas add lines keeps that correct connect the dots. So add lines is going to be the safer option. So it's better to be a bit more explicit about how we want that connection to be done. Now, suppose we're making a time series plot for multiple lines. We're going to demonstrate how Plotly handles this with a new data set. So the data set that we're going to work with is called the economics data. So it has some dates and some information about the unemployment rate. So the way that this time series is going to work is we want to have a line for every single year. In order to do that, we need to actually group by what is going to represent each different line. So in the data that is passed to Plotly beforehand, we need to group by the variable that specifies what each line represents. So I need to take my econ data and I need to group by year. And then I can add in my line plot like usual. And we'll take that group by argument away to show you the effect that group by has. But first we'll do it correct. So X, we'll set that equal to month. So we just had some modifications. So for every single year, we create the year column. And for month of the year, we create the month. So our x-axis is going to be the month. Y-axis is going to be the unemployment rate. And then we'll do add lines. And we'll get the text for the year. So let's run this. So this gives us this output here. So we get one line for every single year because I grouped by year. So that's how it connects the dots. It connects the dots across the months for each year, gives me a different line for every single year. If I take away the group by, we get this sawtooth pattern because it doesn't know how to connect the dots. It doesn't know to group them by the year. So that is why we want to have the group by statement in there. But a little bit behind the scenes, how Plotly is working is when we specify it like this, there's just one trace. So one trace, one layer that has every single year, that has every single line. So the interactivity, we can't really compare year to year. I have to find every single individual value. So if we want to get more interactivity into this plot, we have to add a new layer for every single different line that we have. To do that, we just have to map a new aesthetic to the year in our code here. So what we can do is copy this. And now I'm going to change the color to, and I want it to be a factor of year. So just an ordered factor. So it's going to put the most recent year on top and the oldest year on the bottom. When I run this, this gives me a different color for every single year, which means there is a new layer for every single line. So I can remove lines like we've seen before in this interactivity. And I can also compare data on hover. It gives me the values for every single year. So behind the scenes, right, there really is a new layer of this plot for every single unique color that we have, every single unique year. So there is a different structure to this plot. So depending on the level of interactivity that you want, that affects how you're going to build your plot. Let's say, for example, though, that we want this interactivity, but having all these different colors doesn't really fit into our narrative. It doesn't add anything to have so many different colors. So what we can do is actually use the split argument. And this guarantees that there's one trace, so one layer per every single group level. And this is very good when we want to leverage a consistent visual property. So the same color line across multiple traces, but still get that interactivity. So to do that, it's super simple. We can just take our previous code And instead of using color, we're going to use the split argument. And I can now specify the color that I want them all to have. So color equals the constant gray. When I run this now, I still get this interactivity. I can take away years to focus on the years that I want. I can still compare all those different values, but I just have a constant color across all those different lines. So that's a pretty neat way that can help us build a narrative, which is what we're going to do next in the application, returning to Gapminder. So we're going to create a time series plot now for life expectancy of each country. So on the x-axis, we're going to have time in years. On the y-axis, we're going to have that life expectancy, and we're going to be kind of tracing along each pattern for every single country. How does their life expectancy change over time? So let's create our first plot. So Gapminder, we want a line for every single country. So we need to group by country before passing it into Plotly. Plotly x equals year, y equals life expectancy, and text equals country. So I want to get the mouse over text for the country. And then we'll do add lines. We'll color them by continent, so we still get that extra information. So here's what we get. So notice that there is kind of a general trend, but there's some countries that don't follow that trend, right? If I look down here, looks like Rwanda, right? They had a civil war, so they are not following that trend for life expectancy. Cambodia as well kind of deviated from that trend. And there's also one in here. And it turns out this line, if I trace it all the way up here, turns out to be China. So if I were to be able to highlight the data on here, it would be China. There we go. That kind of doesn't really follow this trend. It has increase, decrease, and then a really big increase in life expectancy. So maybe our narrative is to focus on just those countries, right? That's going to be the interesting part of this story. So typically, when we're working through a data analysis, we're creating a bunch of plots, or maybe just using some easy interactivity with ggplotly. That's kind of the recommended way. But then once we figure out a narrative, once we figure out what we want to do, then we can switch over to Plotly in order to customize the interactivity to further our narrative. So we're going to create a polished plot where we are focusing on just these three countries and making everything else fade to the background. The way we do that is going to be via color and by specifying the mouse over text. So what we want to do first is let's go ahead and change the colors on all of the lines other than just the three countries that we want. So to do that, we actually have to do this in layers. So the first thing that we're going to do is remove the color by continent. So we're going to set this to a constant gray. So step one is just make everything blend into the background. So that's how we can do that. Next, what we want to do is get rid of all the interactive information so that it's not kind of overplotting when I'm working through this data. I only want to show the interactivity for these three countries. What we can do to do that is specify the hover info and set that equal to skip. So how did I know to do that? Well, if I look at the schema, I mentioned earlier that a lot of these line plots and different plots that we're making are actually behind the scenes based on the JavaScript type called scatter. So scatter, if I go to attributes and I'm looking for something related to the hover info, if I set this to none or skip, no information is displayed, right? So that's how we can use schema, is if I want to do something, I look for a relevant argument and see what values it can take. So set this to skip. When I run this, now there's no mouse over information for any of these countries. Good, so we're getting closer. So now we're going to use a previous idea called Plotly data to investigate the data behind the scenes of this plot. So right now, my line plot is built off of that raw data. It's just looking at every single row. There hasn't been any operations done to it. If I just want to focus on those 3 countries, we need to narrow down our data to just those 3 countries. So what we can do is use a filter statement. So filter, we'll do country in percent in percent, and we'll give it a vector of those 3 countries. So those 3 countries were Cambodia, China, and Rwanda. So if I just look at those 3 countries now, we can add a layer just based on them. So if I Plotly data that for debugging, make sure I have the rows that I need. Looks like I just have Cambodia, China, and Rwanda. Perfect. So I can comment that out. And now I'm going to add a new layer of add lines. And I do want mouse over info. So I do want these to display what country. And I also want to change the color to make them emphasized. And to bring them out, I will do a constant red. And now we have highlighted these countries, really bringing out the narrative. So we see generally that these do not follow the trend, and we can get into specifically which countries those are and their life expectancy as time goes along, right? This would be the final communication piece. This would be what drives your narrative home to your audience. So next up, we will learn some fancier types of plots in Plotly, and we'll pick up with that in the next video.